All right, my Gator friends, a quick warm-up here before we get started on 4.11, which is really going to go into detail about exponential growth and decay. But just a quick recap when we're talking about exponential functions, that this is our standard equation right here, which we will see f of x, which is also our y value. F of x is equal to a times b to the x power. That's our input right there, our x value. So anywhere that you see green on here, that represents our input, the exponent value. And anywhere that you see blue, that would be our output in any given function. Okay, so in 4.11, as I mentioned on an earlier video, is that b, which is our common multiplier or our successive quotient, our common ratio, that we are looking at. If it's greater than 1, then it's going to be growth. If it's less than 1, it's going to be decay. And this r right here, this rate is going to be a percentage. And so we're going to do a little practice on converting that percentage into a decimal to make sure that we get an accurate multiplicative rate of change. So here's a table of values. I have my inputs. My exponent is going to be, if it's a 0, then I get a 4 in my output, my y value. If I input a 1, I get a 12, 2, 36, 3, 108, 4, 324. What I'd like you to do is I just set it up right here. I have a function is equal to, what I'd like you to do first is to take a quick second to see if you can figure out, based on the table of values, what will my a be? What's my initial value going to be? Okay, you got it? So what you should have noticed is that if x is 0, that my 4 right here, this right here would be representative of my starting value. So I'm going to put a 4 right here. Okay, the next piece would be what is the rate of change here? It's going up by a common multiplier or a common ratio. So if we look at this right here, we're going from 4 to 12. I can do 12 divided by 4. That's my ratio. I'm comparing two numbers and finding the quotient, so I'm using division. As 3, I'm going to do the same thing here. I'm going to do 36 divided by 12 equals 3. Some of you that are very familiar with multiples of 3 are seeing this straight away, and multiples of 4 as well. So then 36, we can go on here that 108 divided by 36 is 3. Okay, so that would mean that our b value right here would be 3. So now I have a function where if I do an input, it will be 4 times 3 to the input power. So let's just take a number like 3. So I'm going to do f of 3. So if I input a 3 into this function, that means that my exponent right here is going to be 3. And if I do the math right here, bring down my 4, 3 times 3 is 9, times 3 is 27. So we're going to multiply this by 27. And then if you continue your calculations, you will find that this is 108. And from a graphing standpoint, that if my input, my x value is 3, then it will be plotted up here at 108. And that would be my value right there. And that's my initial value would be right there, and 2 and 36. And so that we'd have a nice exponential graph that looks something like this. And then it gets very close to 0, but never touches. And that's our warm-up for today.